So use the definition of a radical and the properties of exponents to simplify the expression of each row of the table. The first row has been done for you. So what did they do to get this first row filled in? So how did they get this 4 times 4? What did they do? Alright, so the square root of 16 is 4. Square root of 16 is 4. So 4 times 4 equals 16. Alright, so then here, the square root of 16, a square root, it has a radical, it has an index of 2, right? Another way of writing it is 16 to the 1/2 power. Get your calculators out. So in your calculator, I'd like for you to parentheses 16 below your parentheses. And then you're going to do your exponent up, so your caret up, and parentheses 1 divided by 2, close your parentheses. And what we're doing is we're putting 16 to the 1/2 power. Division is just another way of writing a fraction. A lot of your calculators have that fraction button. But if you are using a different calculator, if you just do 1 divided by 2, that's the same as 1/2. So we'll do 16 power up, parentheses 1 divided by 2, or 1/2, however your calculator works. And then close your parentheses, and then push enter. What number do you get? 4. Now, obviously, that is less convenient than just pushing the square root button and entering 16, right? But this is another way of doing it. Sometimes we get exponents that are other fractions, and so we need to know how to put those into the calculator, because sometimes that math can be complicated and tedious, and the whole purpose of a calculator is a tool, and a tool is only useful if you know how to use it properly, right? Alright, so here we have the cube root of 3. So cube root means how many on the inside? 3. 3 on the inside makes 1 on the outside. So 8. What's our factorization of that? 2 times 4, and then 4 is. So this can be rewritten as 2 times 2 times 2. Alright, so these 3 2's, when they escape, how many escape out? 2. So this is 2 times 2 times 2, right? Based on your homework. So what's 2 times 2 times 2? 8. Alright, 8 to the 1/3. So if we input this into your calculator, what are you going to get? Hopefully we get 2, based on what we just did. But let's check on our calculator. Alright, and 2 times 2 times 2 is still 8, right? So that equals.
Just added the 3/3 together. Yeah. It's a 16 and a half, 16 and a half.
I'm confused. So 8 to the 1/3. Oh, I see. So 8.
You add all the exponents and you get 1.
Okay. Alright, so do you want to try this next one? So we have the 4th root of 81. So what's your first step? much equate things that these keep working out nice and perfect, right? Alright, so 81 is the same as 3 times 3 times 3 times 3, right? So the fourth root of 81, we need groups of 4. So here we have a group of 4 threes. 4 threes on the inside make how many on the outside? 1, 3. So this is the same as 3 times 3 times 3 times 3. Or here we have, or this equals 81. Here we have 81 to the 1/4. And since our bases are all the same here, what do we do with our exponents? Add them together. And 1/4 plus 1/4 plus 1/4 plus 1/4. That's 1. We have 4/4 equal 81 to the 1 power, or just 81. Alright, so saving the best for last, we have the square root of a times the square root of a. So based on the pattern that you've observed, what do you think that is? Alright, so square root of a times square root of a would be the same as the square root of a squared, or square root of a times a. So just a. And so a to the 1/2 times a to the 1/2 is to the first, because 1/2 plus 1/2 equals a to the 1, or just a. All right, number 7 says identify and describe any patterns in the table. Write a to the 1/n as a radical expression. All right, so now we're getting out there. So how would we write a to the 1n as an expression? What does this pattern tell us? How does the fractional exponent form compare to the radical form? Compare these two columns. Okay, so our index here is the denominator. So 1/3 has a denominator of 3 and has an index of 3. 1/4 has a denominator of 4 and our index is 4. And if it's a half, our index is 2 or square root. So we can write this as with our radical. A on the inside, our base goes on the inside. And what's our index going to be? N. That's okay. So we're learning the terms. The level of radicalness. Questions before we go on? All right, so the general rule for the fractional exponents when the numerator is not 1 is a to the m over n. So here we have a numerator of m and a denominator of n. So our base goes inside here, and then our denominator is our index, and m is the power inside. So we can write it like this, or we can rewrite it. It can also be written as the nth root of a to the m power. So what's important here is knowing where your numerator and denominator go. So numerator is the power, whether it's inside your root or outside. Your base is inside your root, and n is your index. So that's telling you how many of your bases you need on the inside to make one on the outside. Are we okay with that? Kind of. All right, so let's look at number 6. So here we have 6 to the 2/3 as a radical expression. So we're going to do two methods, where this is your method number 1 and this is method number 2. They both will give you the same thing. So here, what's important to know, what's our base? What's our base here? So our base is 6, so we can draw our roots and put our 6 inside. What's our index on our root? How many do we need on the inside to make one on the outside? 3. It's our denominator. This is our index. So then 2, our numerator, is how many of the bases we have? Well, here we have 2 6s. Now, where else could we put our 2? We can put it the whole thing in parentheses. It's, yeah, depending on how your equation is set up and what you're trying to do. So let's test that on our calculators. So on your calculator, I want you to do, how many of you have a root button where you can like put in your index? Okay, so some of you do. So what I want you to do, if your calculator is set up that way, and it'll look something like that, right? So push that button and put a 3 in for your index. Put a 6 squared. And then I want you to do another one where you have parentheses in that same box. But then close it and then raise that to a power of 2. And we should get the same thing. So looking at Desmos, we can do we get 3.3, and on here I'm getting the same thing. So each way we got the same thing. So 3.3 is what you should get each time. So that gives you 3 different ways to set it up. Why all the differences? Well, as we get into different math, and we know life is complicated, right? Well, guess what? When life is complicated, the equations that we have to use to figure things out also are complicated. And so as we move forward, we'll be manipulating equations, and sometimes it's easier to have fractional exponents. Sometimes it's easier to square the whole thing. Sometimes it's easier to square what's inside. And so when you know how to use all methods, and you know when things are equivalent, you can make your life easier. All right, so let's look back. So write each of the following as a radical expression. So let's look at A. How do we write that as a radical expression? So I want you to give this a shot. So think about, what's my base, what's my index, and what's the power on the base. So we want to write it as a radical expression. So that means we want the little root thing in there. Alright, so what's our base? What's the base? 13, so where does the base go? Inside. What's the power on the base? How many of them do we have? We have 1. And what's our index? Right. Do we feel comfortable with those? That's going to wrap up 20.1. So let's move into 20.2. And here, all of that knowledge that we just worked, we're going to apply it to adding and subtracting radical expressions. So again, we're talking with the Windy Hill Science Club advisor, and she wants to, or he wants to, find the total length of the balsa wood needed to make the frames for the kites. To do so, he will need to add radicals. All right, so when we work with, I want to kind of go back to what we already know. When we add or subtract fractions, what has to be true about the denominators? They have to be the same. All right, so there's some rules when we add and subtract radicals. All right, so when we add and subtract radicals, the index and the radicand or the base have to be the same. So here, the number in front can be different, but if we have square root of b or root of b, that has to be the same. You can't add a square root and a cube root together. They're two different things. It's kind of like an x squared and an x. We don't combine them because they have different values, right? Well, the cube root of a number and the square root of a number have different values, correct? So we can't just add them together when they're in this form. So the square root of b, so we have a plus the square root of b plus the c square root of b. So this is saying we have a square root of b's, and this is saying we have c square root of b's. When we add them together, we're adding or subtracting the a and c. So let's do some practice ones. So here we have 3 square root of 5 plus 7 square root of 5. So this is saying we have 3 square roots of 5, right? And this is saying we have 7 square roots of 5. When we add it together, we're taking 3 plus 7. When we add them together, we have 10 square root of 5. Questions on that? Okay. So now to get the actual value, you can put it in your calculator, 10 times the square root of 5, and that would give you the value of it. But keeping it in irrational form, you can stop there. So here we have 10 cube root of 3 minus 4 cube root of 3. First thing we need to look at is, are they the same index? And do we have the same number inside? So these are both cube root of 3's, so we can go ahead and subtract them. This is saying I have 10 times the cube root of 3, and I'm subtracting 4 of them away. So what are we left with? 6 cube root of 3. All right, so let's look at C. We have a combination of square root of 5's and square root of 3's, right? Can we combine? Can we add square root of 5 and square root of 3 to get square root of 8? No. And on your calculators, is the square root of 5 plus the square root of 3, does it equal the square root of 8? So I got 3.97 when I take square root of 5 plus square root of 3. And then the square root of 8 is 2.82. So when I add these together, do they equal that? No. So can we just add them together? No. All right, so be very careful with that because that's probably going to be the easiest thing to do. The rules for adding and subtracting radicals is closer to, rules for when we're working with x or rules when we're working with fractions than just regular numbers. Because these regular numbers? No, we have that square root or we have the root going on, so there's a process going on. There's an operation going on to manipulate the number before we add or subtract. So here, what I'd say is let's go through and find all of the square root of 5s first. And let's group those together. So we have 2 square root of 5 plus 6 square root of 5. So how many square root of 5s do we have first? We have 2, and then we're adding 6 more square root of 5. So how many square root of 5s do we have? 8. And then let's look at our square root of 3s. We have 3 here, and then we have 8 here, and we're subtracting 3. So if we had 8 square root of 3s, and we're subtracting out 3 of them, how many do we have left? We had 8, and we're losing 3. We have 5. And that's essentially what they have written over here. So we have 8 square root of 5 plus 5 square root of 3. And that's it. We don't write it in any other way. We just leave it like that. And that's in irrational form. And remember, irrational just means that we can't write it as a fraction. It's some decimal that goes on forever. And that's okay. All right, so let's look at A. We have 2 square root of 7 plus 3 square root of 7 plus 2/3. So the first thing that we need to do is we know we're adding irrational numbers, right? Remember, irrational numbers are, if somebody's acting irrational, how are they behaving? Not rational. Odd, right? In a way that you can't relate to, right? So an irrational number is the same thing. A rational number, you can make sense of it. We can write it as a fraction. Irrational, it's kind of out there. We don't understand how it's behaving. It just keeps going on and on, rambling, repeating, kind of going in different directions. And so it's okay. 2/3, that's rational, right? We can make sense of that. We know we have 2 out of 3 pieces. These, I don't know what the square root of 7 is off the top of my head. I'd have to look, and even then I'm not going to get a solid. I'm going to get an estimation on the calculator because the decimals are going to keep on going. Alright, so here we have 2 square root of 7 plus 3 square root of 7. So how many square roots of 7 do we have? 5, right? We have 2, and then we're adding 3 more. So 5 square root of 7. Can we combine that with a 2/3? Can we combine an irrational number and a rational number? No. So then we just leave it be. Because this is 5 times the square root of 7 plus 2/3. And remember, to add fractions, the denominators have to be the same. Alright, so what about B? Why don't you try this one? And then we will go on to the next. So we start with square root of 5. So we have 2 here and 7 there. So how many square root of 5s do we have? We have a total of 9. Then what? We're going to look at the other one. So we have 5 square root of 6 here. And how many square root of 6s are we subtracting? 1. So we had 5. Doing 1. And then we just stop. And that's good to go. All right. Questions? All right. So how do we do 6? Square root of 2s. Okay, so this one. Yeah, let's do this first step. So we have 2 plus, we have 2 square root of 2. Alright, so square root of 8. 8 we can factor, right? So that's 2 and 4. So it's a square root. How many do we need on the inside to make 1 on the outside? 2. So I have 2 2's on the inside. Those 2 2's on the inside make how many on the outside? How many can escape the prison? The radical prison. Alright, so we have 2 square root of 2. So this square root of 8 can be replaced with 2 square root of 2. These are both square root of 2's, right? So how many do we have? Now, that 2 on the end, can we, throw that in there somehow? No, because it's not a square root of 2. It's a whole number. It's rational, and we can't combine rational numbers with irrational numbers. All right, questions with that? All right, so the club advisor needs to know how much wood to buy for the legs of the kite. Each kite will be 3 feet tall. All right, so go through, and I think we did this, the length of the crossbar, right, on Friday. So let's go through and copy in that table real quick. All right, so we copied the length of one crossbar from Friday's lesson from 20.1. And then this is saying that the length of each leg, the kite will be 3 feet tall, which is the length of one leg. Wood needed for the legs. So we have 4 of them, right? So to get this, we'll multiply. And then what about the crossbars? How many crossbars did our kite have? It had 4 pairs, right? So 4 pair. It had 4 pairs, or a total of 8. So I need this 8 times, right? So we have square root of 2 plus square root of 2. So how many square roots of 2 will we have? So this would be 8 square root of 2 plus 1 plus 1 plus 1 plus 1, blah, blah, blah. So we can write that as 8 square root of 2. Does that make sense? 1 plus 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 1. So how many feet do we need for this one? This can be reduced, right? Let's just leave it. How many square root of 8s do we need? And how many square roots of 18 do we need? How many square root of 5s do we need? How many square roots of 20 do we need? How many square roots of 45 do we need? Alright, so let's some of these, like this one, and this one, we can reduce that number inside, right? So let's go ahead and do that. So 8 square root of 8. 8 factorizes to 2 times 4. So these two on the inside make how many on the outside? So now we have 8 times 2 square root of 2. So 8 times 2 is 16 square root of 2. So that we can rewrite as 16 square root of 2. I'm going to stop there because the bell's going to ring here in a minute.